going to do the section 1 of the exam. So let's start with this first problem. The limit of x approaches 9 of f of x. So first we want to go to the function of this problem where it says provide, you use the provided for graphs for f of x and g of x. So here we go. So our objective is to find where the limit of x approaches 9. So we want to find where 9 is. Since 9 is over here, you want to see where it's approaching. Since the left and the right are approaching -1, since they're going upwards, we know that this is going to be -1. So this equals -1. So the limit of x approaching 9 from the left of f of x equals the limit of x approaching 9 from the right of f of x equals -1. Okay, so we can do the same thing. The limit x approaches -1 from f of x. So let's go find -1. As this we can see, this is not the same, and there's something different about this function. From the left, we can see this approaches -infinity since of the asymptote. However, from the right, we can see there's a point at 5 from the right. We know this is not going to be a value since the limit of x approaching -1 from the left of f of x equals -infinity does not equal the limit of x approaching -1, -1, and -1 from the left, from the right, f of x equals 5. Therefore, this one does not exist. D and E. Okay. Next, we're going to find limit of x approaching 12 of g of x. So let me change it to color right here. Let me change it to purple, something that's more visual. So g of x. Oh, okay. G of x of 12. So let's go find 12. Here we go. 12 is right here for a g of x function. Since we know the limit of something must equal the left and the right. It must be true. So the left and the right doesn't equal the same. Since the right side, there is nothing. So this one does not exist, since it's only one-sided bound. It does not exist one-sided. Okay, let's go for x approaching 1 from g of x. From 1, here we go. From 1 from the left, we can see it goes to -1. But from the right, it goes to -3. And left, well, -1 and -3 does not equal the same. So this one does not exist either. Because -1 does not equal here we go. A bit struggling over here. Does not equal 3. And let me put g of x, 3. Okay. Let's go for this one as x approaching 7 of g of x. So let's go find 7. Okay, for 7, this one looks like a problem. However, there might be a big confusion with the circle. The circle does not mean anything, does not change any values when the limits. Since as we approach from the left and the right, they're both the same value. Since they're both approaching, what is this? 7. Since it approaches 7, 7, the left and the right, that means this value is equal to 7. Since limit x approaching 7 equals from the left and the right. Okay, let's do f of x now. From -1 from the left. Alright, let's do that one. -1 from the left. As we had this one before, this one was approaching -infinity. Since it was going lower and lower and lower right here. So this one would go to -infinity. Now let's do the same thing with the right side. Since we know this one has a value, since it stops somewhere, like right here at 5. And from the right side, each time you get closer to -1, it will approach at -5. Therefore, This one equals 5. Okay, let's do something a bit more complicated. So this limit of f approaching 5 from f of x of g of x. Okay, to make this a bit more simpler in the eyes, we can just separate the function, which was one of the rules. F of x plus the limit of x approaching 5 from the left of g of x. Okay, this one looks easier. All we have to do is just find the limit of 5 from the left and 5 from the left of f of x and g of x. So let's go find it. So from f of x, from 5 from the left, that's where 5 is from the left, right here. 5 from the left would be 3. 3, here we go. Since we're approaching left and we see it's approaching 3, ever so slightly. Okay, so we know that one's 3. Equals 3 plus, let's put a parentheses because we don't know if it's negative or positive. So let's go find 5 from the left of g of x. Okay. From the left, we see 5 is approaching negative 1. So we plug this in back in here, and we get 3 minus plus minus 1. That would give us 2. So this function would be 2. There we go. Pretty easy, right? We're going to do the same thing from the right side, however. This one's left, and this one's right. Okay, let's go find them. F of x from the right side of 5. Okay, this one will approach negative 1 from f of x. Let's go write that one down. Negative 1 plus g of x. Let's go find g of x from 5 from positive. If positive would be here. And from the right side, so that would be 3. So that would be 1 plus 3, which is still 2. And from the left, I'm going to call this h of x. Let me say f of x plus g of x equals h of x equals the limit of 5 plus of h of x, which equals 2. Okay. We figured that out. Now, let's go back to this problem over here. Let's go to the next problem. A bit more difficult, but shouldn't be too much difficult. We can do the same thing as we did before and rewrite the function, which is the limit of x approaching 12. That's a bit too dark of a color. Let's go for something a bit more darker. Okay, let's do that. Let's do this one. The limit of x approaching 12 from the left of 2 of f of x times the limit of x approaching 12 from the left of g of x. The same property, however, we just took it out, and we were able to take out 2 and f of x from the same value since 2 was attached to f of x. Okay, we can do something further, but we just want to keep everything similar so we don't complicate ourselves too much. Okay, let's go find 12 from the left of f of x first. 12, here we go. We found 12 right here. From the left, we see it's approaching negative 1. Since we can see this entire line, it's approaching negative 1. So there we go. We got negative 1. Let's always put it parentheses. However, we need to do 2 times negative 1 times. Okay, since we're timesing this 2 in front of us. Can't forget that. And we need to times it by g of x of 12 from the left side. 12 from the left side, it looks like we already solved this one once, which was 6 times 6. So negative 2 times 6 would equal negative 12. There we go. We got our answer. Let's go something back, something more, a bit more vibrant. Let's go back to purple. Okay, for this problem, we'll have to find the limit of x approaching 9 of g of f of x. So something that is not apparent is we have to rewrite this function as g as limit of x approaching 9 of f of x, which limit of x is 9, as we can see over here, looks like we solved this once before, is at negative 1. So all we have to do is rewrite this as g of negative 1, which is like that, pretty simple, and we just have to find where g of negative 1 is. g of the negative 1. And right here. So we can assume this is going to be looks a bit like a root function, root over 2, since it's not over exactly, so we can do that. However, this root over 2 is minus 1, since it usually starts at 0. So this is going to be root over 2 minus 1. There we go. And then the bonus one. Let's do the bonus one since we have enough time. So let's do the limit. We're going to do the same thing. F of the limit of x approaching 4 of f of x. Let's go find 4. The limit of 4 right here. Oh, that looks easy. So left and right equal the same, so this is going to be 5. So let's go plug that in. F of 5 equals f of 5. And all we have to do is go find f of 5, which is right here. Oh no, there's something different here. There's 2 values at f of 5. The one we go with is the solid one. The solid one tells us exact value of the function, not the limit, the function. So let's go find this number. This dot is going to go as to 3. So this function would equals 3. And that will be it. Thank you.